My name is Taeyeon Kim, a professor from Yonsei University. I am the leader of the third team of SPMC. I am very pleased to have a chance to introduce my research. To introduce our project, we aimed to diagnose the school indoor air quality by measuring fine particles. And we also aimed to develop integrated technology in order to improve indoor air quality. Today, I'd like to share our ongoing research on consultation on air environment improvement according to school type and demonstration of customized air environment improvement plan. I will explain it in the following table of contents. Here are the contents for today's presentation. Today in Korea, since the fine particle concentration in the atmosphere has increased, it has become a big issue. High outdoor particle concentration is one of the primary factors that influence indoor particle concentration. Also, high indoor particle concentration has adverse health effects, especially on children and the elderly, who spend most of their time indoors, such as schools and residences. In this project, considering the students' long-term exposure in school, our research conducted for the elementary, middle, and high school. Based on this background, the Ministry of Education in Korea announced the standard for the installation and management of air purification system in schools. According to this standard, air filtration systems are installed in all kindergartens, elementary schools, and middle and high schools. However, most of the schools simply installed air cleaners and ventilation systems without considering the conditions or surroundings of school buildings, which brings us to other issues. Since the window has been closed for a long time while operating air cleaner, the CO2 concentration increased significantly. In some classrooms, even the air cleaner were turned on, it could not prevent fine particles from entering through windows and building cracks. Therefore, in order to remove fine particles in school, it is necessary to provide a comprehensive diagnosis of school and a customized improvement method based on the diagnosis result. So, this study aimed to diagnose fine particles and develop processes and guidelines improving the indoor air quality depending on each characteristics of the building. Validation of the developed diagnostics, improvement processes, and guidelines will also be carried out by applying them to actual schools. These figures show the current status of air filtration systems in schools in Korea. According to the Ministry of Education's plan, air filtration systems are being installed in all schools, especially considering the children's weak immune system. Almost all kindergartens and elementary schools have air filtration systems installed. 70% of schools installed air cleaners as air filtration systems, and some schools have mechanical ventilation systems. Many schools tend to prefer air cleaners because they are cheap and easy to install. But these are some limitations in solving these indoor particle problems by using air purifiers. Just as the indoor particle is a paramount issue, the indoor CO2 concentration is also an important factor affecting students. This graph shows PM2.5 and CO2 concentration in the classroom where the air cleaner is installed. As you can see, the concentration of fine particles is kept below 10 microgram per cubic meter due to the air cleaner's operation. However, after class began, just ventilation was hardly performed. CO2 concentration in some classrooms exceeded 2000 ppm. Therefore, as mentioned earlier, merely installing air cleaners could not be the best solution. We need a comprehensive solution for the indoor air quality, considering not only fine particle concentration, but also CO2 concentration. Now, here are the general. In order to solve these problems, our research team established 6 core values. Please see the slide. Based on these values, we set 7 key goals in the study. The goal is to maintain indoor particle concentration below the WHO air quality standard of 10 microgram per cubic meters and CO2 concentration below 1000 ppm. Other goals, please see the slide. In this study, we conducted a consulting project of schools and demonstration projects for improving the customized air environment to maintain the healthy air environment of the existing schools. In order to achieve this goal, the study is divided into 4 subtasks, as seen in the slide. To conduct a research, each team will play the following roles to carry out the improvement of demonstration project for the existing schools, which is the ultimate goal of this study. The following is a demonstration of process for this project. We will carry out demonstration projects in the order of diagnosis, consultation, system selection, company selection, stability leave, post-occupancy evaluation, and feedback. In this process, we plan to collect opinions from teachers and students at school and carry out occupancy-friendly project. The existing schools improvement strategies will provide an optimized system for each type of space, such as a general classroom, a particular activity classroom, and large rooms. The improvement project is divided into 3 categories: architectural improvement, mechanical system improvement, and maintenances. One of the most essential architectural improvements is to improve the air tightness. In Korea, the outdoor particle concentration is often high due to various problems. Therefore, in this study, the priority is to supplement the air tightness to minimize the effect of the outdoor particle concentration on indoor spaces. Mechanical improvements are based on a comprehensive assessment of indoor air quality, thermal comfort, and energy performance. Moreover, we analyzed the problems in the indoor environment and apply the proper mechanical systems. In the process, we will apply the simulation analysis or data analysis technique. The project will be further improved by continuous monitoring and feedback. Now, here is the demonstration project that was already carried out in 2019. This picture shows the diagnosis result of J Middle School located in Seoul. A comprehensive evaluation was conducted considering the general information of the school, the information of the mechanical equipment, and the current management status. In 2019, our research team visited the site and performed building evaluations and simulation analysis. And we had a meeting with teachers in schools to reflect their opinions and establish an improvement strategies. As a result, we installed additional ventilation systems and air cleaners. This picture shows a stand-type ventilation system and air cleaner installed in the classroom. After collecting opinions from the school, we installed a stand-type ventilation system that does not require a ceiling diffuser. In addition, a ventilation system that combined with air cleaner function was installed to prepare for high outdoor particle concentration. So, here are the final outcomes of the study. First of all, we will conduct diagnosis and consulting at 100 locations. For each project, we will provide a brief report on diagnosis and consulting result. Based on this result, we plan to conduct improvement projects in 50 locations. We will analyze the improvement effect by comparing the 50 improved locations before and after the improvement project. In particular, we will also ask teachers and students about their awareness or satisfaction of the changed system to identify the occupants' satisfaction. Second, we would like to develop the following standard operation procedures for improving the air environment. Next, we are planning to create a website to share our research results. The results of our research and real-time monitoring data of the Living Lab will be updated on this website. Also, various analysis methods, results, and data from multiple schools will be compared and uploaded. Finally, a comprehensive handbook will be published covering the entire process of diagnosis, consulting, improvement, evaluation, and maintenance. This handbook will be provided to each consulting institution, government department, school, and so on. And this will be used as educational materials and manuals. Finally, a comprehensive handbook will be published covering the entire process of diagnosis, consulting, improvement, evaluation, and maintenance. This handbook will be provided to each consulting institution, government department, school, and so on. And this will be used as educational materials and manuals. So this is all for today. Thank you for listening.